All right, quick quiz. Here we go. Put two blanks out here. We practiced it once. Don't say the words. Write in the words, the other words that are either X, Y, domain, range, input, output. They're alphabetical. Write them in. Noah, where are your notes? All right, write them in. Check your spelling. Okay, so abscissa is the first one, and ordinate is the second one. Now, I've added two new pieces here. The independent variable and the dependent variable. Independent is the one that decides what's going to happen. That's why it's called the independent. It's the one case where they're not alphabetical. So you have to just be aware of that fact. The independent makes the determination for what the y value will be. So, couple ideas here. Our goal today is to be given a table and then try to write the equation. So I need to teach you some tricks as to how to do this. Things to look for. Look for the x's and y's to have a common difference. In other words, you subtract the y minus the x and you always get the same number. Look for them to have a common multiplier, a ratio. Look for them to maybe have a common sum. And so we're looking for all these different possibilities to try to recognize certain patterns in them. In an extreme, look for squares. If you look for squares, that's going to give you a parabola shape. So we're going to try to look for patterns here. So I have a couple illustrations down here as examples. Look for a pattern. 1 to 6, 2 to 7, 3 to 8, 5 to 10. Do you see a pattern? What's the common difference? 5, because 6 minus 1 is 5. 7 minus 2 is 5. 8 minus 3 is 5. 10 minus 5 is 5. So the common difference is 5. So you could say y minus 5 equals x, right? That would be one way to write it. But we always typically want to write our equations with y equals. So how could I say this y equals? How do you change the x and make it the y? You say x plus 5. So that would be one method to say it. Or the book might just as easily say f of x equals x plus 5. Both of those are viable answers. So you're looking for the pattern. Look at the pattern here. If you see it, raise your hand. 1 to 3, 2 to 6, 0 to 0, -1 to -3. Does anyone see a pattern? How does 1 become 3, 2 becomes 6, 0 becomes 0? Well, let's look. 3 minus 1 is 2. 6 minus 2 is 4. So is there a common difference? No. Look for a common ratio. What's 3 divided by 1? What's 6 divided by 2? 3. 0 divided by 0? -3 divided by -1? 3. Does it look like there might be a common ratio? The common ratio is always the second number divided by the first number. So in this case, the ratio is y divided by x. So the equation would look like this. Y equals, what was that ratio when we divided each one? It was 3, okay? 6 over 2 equals 3. So the ratio is 3x. Does that work with the 0, 0, 1? Plug in 0. What's 3 times 0? So does it work? So the common ratio is 3 times 0. Let's look over here. Let's try the common difference. What's 3 minus 5? -2. 4 minus 4. So there's no common difference. Let's look at the common ratio. What's 3 divided by 5? 0.6. What's 4 divided by 4? 1. So it's not a common difference. Look for a common sum. What's 3 plus 5? 4 plus 4? 5 plus 3. Do they all add to 8? So the common sum means you add, is how much? 8. How do I write this, though, as y equals? Y equals 8 minus x. All right? Zach, you've been patient. What's your question?
Couldn't there be a common difference? Because if you get 3 minus 5, it's negative 2. 4 minus 4 is 0. Keeps increasing by 2.
Common. Common means the same difference on every single one.
Well, would that still be a pattern, though?
It is a pattern, but the pattern isn't a common difference. It's a common sum. So when I say the common difference, I mean 6 minus 1 is 5. 7 minus 2 is 5. 8 minus 3 is 5. They have a common number when you subtract them all. In this case, the common difference is 5. Here we have a common sum. So a lot of different scenarios there. Okay? You'll see some tables given to you on the homework today. You're going to try to figure out which of these patterns it fits with. Your final result, though, Sam, you want to always end up having y equals, y equals, y equals. All right. Come down here to the bottom. I am a lover of cookie dough. Chocolate chip cookie dough. I will confess, I often have my wife go to Costco and she buys me a tub of cookie dough. There's only one flavor, by the way. Chocolate chip. All right, so we have our chocolate chip cookie dough tub. And she goes and she does a unit pricing because she wants to make sure she gets the best price per pound. You have to buy it by the pound, of course. You can't buy it for just a little bit. So she's determined and found that the price per pound that's the best price per pound is 38 cents per pound. So I want to write a function rule that represents how much it's going to cost to buy an unknown amount of cookie dough. Now, C represents the amount. So if I want to find how much cookie dough it's going to cost, I'm going to say 38 cents times C. That's my function. Now, what does that equal? What do you think this TC stands for? What do you think the T stands for? The total. So the total, in terms of C, is 38 cents times C. So that would be said T of C. If you said X is the cookie dough, then you'd have T of X. If you said A was the cookie dough, you'd have T of A. So depending on what we have there, that's going to be a function. If we did a different illustration and Jalan got 2 points for every shot that he made on the basketball court, okay? In terms of X being the number of shots he takes, J stands for Jalan. I would say for every shot he takes, he gets 2 points. What's my function going to look like? 2x. Now, is it possible to make a basketball point other than a 2-point shot? Yeah. So this is not necessarily going to cover all the situations. This assumes the only shots he's taking are 2-point shots. All right? So that's the case in terms of that. All right, let's flip it over.